Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a quarter circle. AOB is a quarter circle. Inside this quarter circle we have quadrilateral AODC, and we have to find out the value of the green quadrilateral ACDO. We also know that side AC of the quadrilateral equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACDO. Okay, so we start with the first method. First of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And also, this point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay, so from point O, that is the center of the circle, we go perpendicular on AC. Again, from point O, we go perpendicular on chord AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Here, point O is the center of this circle, and from point O we have perpendicular OM to chord AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then according to this rule number 11, perpendicular OM to chord AB will also bisect chord AB. That is to say, AM equals to MB. Okay, again, the perpendicular from the center of the circle, that is OM, not only perpendicular to chord AB, but it also bisects chord AB. That is to say, AM equals to MB. We actually can implement rule number 11 in our drawing. Why? Because in our drawing, point O is the center of the circle that we can create by completing this quarter circle to a circle. So from the center of the circle, that is to say from point O, we draw perpendicular OP to chord AC. Okay? OP is perpendicular to AC. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And therefore, according to rule number 11, OP will also bisect chord AC. That is to say, AP equals to PC. Okay, AP equals to PC according to rule number 11. And because of the fact that AC equals to 24 units, So each half of AC will be equal to 24 over 2. 24 over 2 is 12. So the first half AP equals to 12 units, and the second half PC will be also equal to 12 units in its length. Okay, so this is the implementation of rule number 11 in our drawing. In the next step, from point D, we will go perpendicular on PO. Again, from point D, we will go perpendicular on PO. So this angle equals to 90 degrees, and this angle equals to 90 degrees also according to our construction. We define the touching point of the perpendicular from point D and PO is Q. So here we actually created quadrilateral PCDQ. Inside quadrilateral PCDQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this fourth angle. In total, the sum of those 4 angles, they must be equal to 360 degrees according to the rule that the sum of the angles in every quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. So actually, inside quadrilateral QPCD, we have 4 right angles, and therefore we relate to quadrilateral QPCD as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side PC of rectangle PCDQ equals to side QD. So PC equals to QD, but PC is 12, therefore QD must be also equal to 12 units in its length. Likewise, in the same rectangle QPCD, side QP must be equal to side DC, but DC is 7, therefore PQ must be also equal to 7 units in its length. Okay, in the next step, we define line segment QO as X. And we will focus on the right triangle OQD. This right triangle OQD, we define angle ODQ as alpha. Again, in the right triangle OQD, this angle equals to alpha according to our definition. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. So we define 90 degrees minus alpha as beta. So the missing angle here must be equal to beta. Angle AOB equals to 90 degrees. This angle POB equals to beta. Therefore, 90 degrees minus beta equals to the missing angle, angle AOP. I write it down. The missing angle AOP is equals to the big angle AOB, that is 90 degrees, minus angle beta. Okay, so 90 degrees minus beta. But beta is 90 degrees minus alpha, so we substitute beta here by 90 degrees minus alpha. we'll open the brackets here and we get that 90 degrees minus 90 degrees is 0 and minus times 1 is plus, so in total this expression equals to alpha. That is to say, the missing angle here, angle AOP, is equals to alpha. Angle AOP equals to alpha. And right here that this is the missing angle AOP, that is equals to alpha. We'll focus on the right angle APO. In this right angle APO, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta. So we can write here that this angle equals to beta. In the next step, I'll copy the right angle OQD, this right angle OQD, in a new page, and find out the value of tangent alpha in this right triangle OQD. Okay. Again, ODQ equals to alpha, QD equals to 12 units, and QO equals to X according to our definition. So actually, this is the right triangle QOD. This is the right triangle QOD that I copied from the original drawing. QD equals to 12, QO equals to X, and this angle equals to alpha. And this right triangle QOD, we get that tangent alpha equals to X over 12. Okay, tangent alpha equals to QO over QD, but QO is X and QD is 12, so in total I can say that tangent alpha equals to X over 12. Okay. In the next step, I'll copy the right triangle PAPO here in the new page and we find out the value of tangent alpha in this right triangle APO. Side AP equals to 12 units. What is the value of PO? Although it is very easy to see that PO equals to 7 plus X. Okay? PO equals to 7 plus X. Angle AOP equals to alpha. Okay. This is the right angle APO that I copied from the original drawing. In this right angle APO, tangent alpha equals to 12 over X plus 7. Okay, again, in this right angle APO, tangent alpha equals to 12 over X plus 7. So we have two different expressions for tangent alpha. Therefore, we create equation number 3. According to equation number 3, tangent alpha, according to equation number 1, must be equal to tangent alpha according to equation number 2. Okay. So, tangent alpha according to equation number 1 equals to x over 12. And it must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 2 is equals to 12 over x plus 7. In conclusion, we found out that x over 12 equals to 12 over x plus 7. Here we cross multiply this equation, and you get that according to equation number 3, x times x plus 7 equals to 12 times 12, that is 144. Here we open the brackets on this side of equation number 3, and you get that according to equation number 3, x times x is x squared plus 7x, that is equals to 144. Here we subtract 144 from this equation, and we get that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula for quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to a special formula. X equals to minus b plus minus the square root of b squared minus 4 times a times c over 2a. Here also a, b, and c are also the coefficients of this general quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we put the data inside the formula for x in order to find out the value of the values of x. I will remind you that according to our definition, line segment QO equals to x. So QO is the length, or x is the length of this line segment QO. So we get that x will be equal to minus b, b is 7, and therefore minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c, that is minus 144, over 2a. A is 2, so 2 times a, 2 times 1 is 2. So we found out that x equals to minus 7 plus minus 4 times minus 144 is plus 576, plus 49 in total it is equal to 625. So inside the root we left only with 625 over 2. So actually found out that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, we found out that x equals to minus 16. But because of the fact that x is a length, as x is a length, and a length must be a positive number, we cancel the solution that x equals to minus 16, that is a negative number, and we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. So 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, we found out that x equals to 9 units in its length. Here, this line segment QO that is equal to x, it is actually equals to 9 units. Okay. Our mission is to find out the area of the green shape that is actually quadrilateral ACDO. So we divide the quadrilateral into 3 parts and calculate the value of each part, and then we'll add the 3 parts together, and this will be the area of this green shape. The first part will be the area of the right green triangle APO. We will define the area of the right green triangle APO as A1. The second part of the green shape will be the area of the right triangle OQD. We define the area of the right triangle OQD as A2, plus the third part will be the area of rectangle QPCD. We define the area of the right triangle QPCD as A3. It is obvious from the following that the total area of the green shape equals to A1 plus A2 plus A3. Okay, so I write it down. The area of the green shape in total is equals to A1 plus A2 plus A3. This is actually the area of the 2 right triangles plus the area of rectangle QC PC DQ. The sum of those 3 areas in total will be equal to the area of the green shape. Repeat again, the area of the green shape equals to A1 plus A2 plus A3. We calculate each area separately, and then we add the 3 areas together. It will be equal to the area of the green shape. Again, A1 is the area of the right triangle APO. So I copy the right triangle APO in a new page and find out the area of this right green triangle APO. Side AB equals to 12 units in its length. Side PO equals to 7 plus x, but x is 9, so in total PO equals to 7 plus 9, that is 16. So actually, this is the right angle APO that I copied from the original drawing. The area of this right angle is the value of A1. So the area of the right angle APO will be equal to AP times PO over 2. Okay, AP times PO over 2. AP is 12 times PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that's actually 96 square units. In conclusion, we found out that A1 equals to 96 square units. That is to say, the area of this right angle APO equals to 96 square units. In the next step, we calculate the area of A2, that is actually the area of the right angle OQD. So I copy the right angle OQD in the new page and we find out the area of this right triangle. Triangle OQD. Side QD equals to 12 units in its length, and side QO equals to x, and x equals to 9. Again, A2 is the area of this right triangle OQD. QD equals to 12 units in its length, and QO equals to 9. The area of this right triangle OQD will be equal to QD times QO over 2. QD is 12 times QO is 9 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is actually 54. We found out that A2, that is the area of this right triangle OQD, equals to 54 units in its length. And finally we find out the area of A3, that is actually the area of this rectangle QPCD. The area of a rectangle equals to the length of the rectangle times the width. The length of the rectangle is PC, and the width is PQ. Okay? The length is PC, and the width is PQ. PC equals to 12 units, and the width PQ equals to 7. So in total, the area of rectangle PCDQ equals to 12 times 7. 12 times 7 is 84. So in conclusion, we found out that A3, that is the area of rectangle PCDQ, equals to 84 square units. I repeat again. In total, the area of the green shape equals to A1 plus A2 plus A3. The area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96, A2 equals to 54, and A3 equals to 84. 96 plus 54 is 150, plus 84, 150 plus 84 it is 234. So the area of the green shape in total is equals to 234 square units. Okay, repeat again. The area of this green shape in total equals to 234 square units. So we finish with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D, we created the right green triangle ACD. So we'll copy the right green triangle ACD in a new page and we find out the length of the hypotenuse AD. So usually this is the right green triangle ACD that I copied from the original drawing. AC equals to 24 and CD equals to 7 units according to what is given us in the question. By PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACD, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 square, that is 576 plus CD square. CD is 7, therefore CD square is 7 square, that is 49. So in total AD square equals to 576 plus 49 equals to 625. We take out of this equation and we get that AD equals to the square root of 625, that is actually 25. We actually found out that the length of the hypotenuse AD of the right triangle ACD equals to 25 units. So we can note here that the hypotenuse AD is equals to 25 units in its length. In the next step, we will do a construction. We will complete the quarter circle to a circle. But first of all, because of the fact that AOB is a quarter circle, this angle must be equal to 90 degrees. Angle AOB must be equal to 90 degrees. And point O is the center of the circle that we will create by completing this quarter circle to a circle. Okay, now we complete this quarter circle AOB to a circle. Point O is the center of the circle. Point A is the point of the circle itself, therefore AO is the radius of this circle. We define the radius of this circle as R, therefore AO is R. This is the radius of this circle. We'll extend the radius AO by a straight line until it touches the circle. And we define the touching point of the extended radius AO and the circle is point M. So AM is a chord that passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of the circle, that is equal to R according to our definition. And indeed, the diameter AM equals to 2R, it is twice as long. The diameter of the circle AM is twice as long as the radius. And AM is the diameter of the circle, that equals to 2R. Okay. In the next step, we will extend side CD by straight line until it touches the circle. The question is where the extended side CD will touch the circle. We will assume that the extended side CD will not touch the circle at point M, but in any other point. For example, we will assume that the extended side CD will touch the circle at this point, point N. Okay? And here we will have peripheral angle ACN that you know that is equal to 90 degrees. It is given us the question. Angle ACD equals to 90 degrees. So we will have here peripheral angle ACN that rests on chord AN that is not the diameter of the circle. The diameter of the circle is AM. But it is impossible that peripheral angle ACN that equals to 90 degrees rests on AN. Why? Because it contradicts rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Peripheral angle MAN equals to 90 degrees, and therefore it rests on MN, that is the diameter of the circle. And because of the fact that peripheral angle ACN, this peripheral angle ACN equals to 90 degrees according to what is given as the question. It doesn't rest on AM, that is the diameter of the circle, but it rests on AN, that is not the diameter of the circle. It contradicts rule number 5. According to rule number 5, peripheral angle ACN that equals to 90 degrees must rest on AM, that is the diameter of the circle. So if we assume that the extended side CD will touch the circle at point N, we get contradiction, because we will have here peripheral angle ACN that is equal to 90 degrees, and it doesn't rest on AM, that is the diameter of the circle. In order to avoid the contradiction to rule number 5, we conclude that peripheral angle AC M rests on AM, that is the diameter of the circle. Exactly according to rule number 5. That is to say, the extended side CD will touch the circle at point M and not in any other point. So here, the extended side CD, touches the circle exactly at point M. So we have here peripheral angle ACM that equals to 90 degrees. According to rule number 5, it must rest on AM. That is the diameter of the circle. You can see here that this peripheral angle is equal to 90 degrees. Indeed rests on AM. This is the diameter of the circle, exactly according to rule number 5. Okay. Now we'll focus on this side of AM. AM is the diameter, it is absolute to a straight line. So we'll focus on this side of the straight line AM at point O. Which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees plus the missing angle, in total the mass is equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay. In the next step, we'll prove that the green right triangle AOD congruent to the white right triangle ODM. Those two right triangles congruent to each other. We'll write it down. The green right triangle AOD congruent to the white triangle ODM. So why those two right angles congruent to each other? First of all, AO equals to OM. AO equals to OM. Repeat again. AO, side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to R, therefore, that is to say they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD in the green triangle equals to angle MOD in the white triangle again. Angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is the common side that belongs to both triangles, so we can write down that OD equals to itself. OD equals to itself. It's a common side that belongs to both triangles. Repeat again. OD equals to itself. It's a common side that belongs to both triangles. We actually proved that the green triangle AOD is congruent. This is the sign of congruent to the right triangle ODM according to side angle side rule. I'll explain what I mean. Those two sides and the angle between them in the green triangle are correspondingly congruent to those two sides and the angle between them in the white triangle. Therefore, those two triangles congruent to each other according to side angle side rule. We have two sides and the angle between them in the green triangle correspondingly congruent to those two sides and the angle between them in the white triangle. Okay? And from the fact that those two right triangles congruent to each other, we will derive that side AD in the green triangle equals to side DM in the white triangle. Okay, again. Side AD in the green triangle equals to side DM in the white triangle. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides AD and DM must be also equal to each other. But AD equals to 25 units. And I tell that AD equals to 25. And from this equation 25 equals to AD equals to DM. We will derive that DM is also equals to 25 units in its length. Side DM equals to 25 units. This is side DM is equals to 25 units. We extended side CD by straight line and we got CM. When we extend the straight line by straight line, the result must be a straight line. Therefore CM or CDM is one straight line. If CDM is one straight line, it means that CM in total will be equal to CD plus DM. Okay? So CM in total equals to CD, that is 7, plus DM, that is 25. So in total CM equals to 25 plus 7, that is 32. So I'll copy the right triangle ACM in a new page and we will implement in this right triangle ACM the Pythagoras theorem. AC equals to 24 units in its length according to what is given us in the question. Again, CM in total equals to 32 units in its length. This is the right triangle ACM, that I copied from the original drawing. According to what is given in the equation, AC equals to 25 units in 24 units in itself. And we just right now found out that CM in total equals to 32 units. AM is the diameter of the circle that equals to 2r. So can I tell that AM equals to 2r? Now, by PT is a equation for Pythagoras theorem. We'll implement on this right triangle ACM the Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACM, we get that AM squared equals to AC squared plus CM squared. AM squared equals to AC squared plus CM squared. AM is 2r, therefore AM squared is 2r squared, that is 4r squared, and it is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. In conclusion, we found out that 4r squared in total, it is equals to 576 plus 1024, in total it is equals to 1600. So we found out that 4r squared equals to 1600, we divide this equation by 4, and finally we get that r squared equals to 1600 over 4 is 400. Here we take a root from this equation, we get that r equals to the square root of 400, that is 20. Because we found out that the radius of this circle r equals to 20 units. In the next step, we'll implement the Pythagoras theorem on the green right triangle AOD in order to find out the length of side OD. So I'll copy the right green triangle AOD in a new page and we'll implement on it the Pythagoras theorem. Triangle AOD. AO is the radius of the circle, that is 20. Hypotenuse AD equals to 25 units in its length. So actually, this is the right green triangle AOD. This is a copy from the original drawing. AO is the radius that is equals to 20 units. AD, the hypotenuse equals to 25 units. Here by PT is the equation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AOD, AD square equals to AO square plus OD square. AD is 25, therefore AD square is 25 squared, that is 625, and it equals to AO square. AO is 20, therefore AO square is 20 squared, that is 400, plus OD square. OD is the missing side, so we leave it as it is. OD square. Here we subtract 400 from this equation, and we get that 625 times 400 is 225, that is equals to OD square. Here we'll take out of this equation. Finally we get that OD equals to the square root of 225, that is actually 15. So we actually found out that the missing side, here side OD of the right triangle OD, is equals to 15 units in its length. So what is the area of this green shape? We'll divide the area of the green shape into two parts. The first part will be the area of the right triangle AOD that we'll define as A1. And the second part will be the area of the right green triangle ACD that we'll define as A2. It is obvious that the sum of the areas of the two right triangles will be equal in total to the area of the green shape. So I write it down. In total, the area of the green shape is equals to A1 plus A2. Repeat again that A1 is the area of the green triangle AOD, so I copy the green triangle AOD in a new page and you find out the area of this green right triangle. AO is 20 and OD is 15. Again, A1 is the area of this green right triangle AOD. The area of this triangle AOD equals to AO times OD over 2. AO is 20 times OD, that is 15, over 2. 20 times 15 is 300, and 300 over 2 is 150. So in conclusion, we found out that A1 equals to 150 square units. That is to say, the area of this right triangle AOD equals to 150 square units plus A2. A2 is the area of the right triangle ADC, so I copy the right green triangle ADC in a new page and find out the area of this green right triangle ACD. So actually A2 is the area of the right triangle ACD. Repeat again A2 is the area of this right triangle ACD. The area of this right triangle ACD equals to AC times CD over 2. AC is 24, CD is 7, divided by 2. 24 over 2 is 12, and 12 times 7 is 84. So in total we found out that A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. Repeat again that the area of the green shape is equals to A1 plus A2. Just as I found out that A1 equals to 150 and A2 equals to 84. 150 plus 84 equals to 234 square units. And that is exactly the area of this green shape. It is 234 square units. We finish with the second method. In the next step, I will summarize the lecture. We start with the first method, of course. In this lecture, we found out the area of this green shape using two different methods. So in the drawing we have a quarter circle. AOB is a quarter circle. Inside this quarter circle we have quadrilateral AODC. And our mission is to find out the area of this quadrilateral AODC. In addition, you know that side AC of the quadrilateral is equal to 24 units, side CD equals to 7 units in length, and this angle ACD equals to 90 degrees. Our mission is to find out the area of the green quadrilateral AODC. So first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay, so from point O, that is the center of the circle, we draw perpendicular to chord AC. Again, from point O, that is the center of the circle, we draw perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O in ACSP. Here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O in the center of the circle. From point O, we do perpendicular OM. OM is perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to this rule number 11, OM is not only perpendicular to AB, but OM also bisects chord AB. That is to say, AM equals to MP. So whenever we have a perpendicular from the center of the circle, the perpendicular also will bisect the chord. Okay? We can implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle, that is to say from point O, we go perpendicular OP to chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to rule number 11, the perpendicular OP also bisect chord AC. That is to say AP equals to PC. So the perpendicular OP divides chord AC into two halves. The first half is AP and the second half is PC. In total AC equals to 24 units. Therefore the first half will be AP, that is 24 over 2, that is 12, and the second half, PC, must be also equal to 12. Okay, AP equals to PC equals to 12. So that is actually the implementation of rule number 11 in our drawing. In the next step, from point D, we do perpendicular on PO. Again, from point D, we do perpendicular on PO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. Actually, in this way, we created quadrilateral PCQD. Inside this quadrilateral, we have 1, 2, 3 angles. This angle equals to 90 degrees according to what is given us in the question. The sum of 3 right angles is 90 times 3 is 270 degrees plus the size of this fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral PQDC we have 4 right angles, therefore we can relate to quadrilateral PQDC as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That is to say PC equals to QD, but PC is 12, therefore QD must be also equal to 12. Likewise, in the same rectangle PQDC, PQ must be equal to CD. But CD is 7, therefore PQ must be equal to 7 units. Then we find the length of line segment QO as X. And we focus on the right triangle QOD. In this right triangle QOD, we defined angle QDO as alpha. So in this right triangle QOD, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. 1 because 90 degrees minus alpha plus alpha is 90 degrees. Plus 90 degrees, in total it is 180 degrees. It is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. We defined 90 degrees minus alpha is beta, therefore the missing angle here must be equal to beta. We know that angle AOB equals to 90 degrees. So 90 degrees minus beta must be equal to the missing angle here, angle AOP. Again, the big angle AOB that is 90 degrees minus beta must be equal to the missing angle AOP. AOP equals to 90 degrees minus beta. So it is 90 degrees minus beta, but beta is 90 degrees minus alpha. So we can substitute beta here by 90 degrees minus alpha. So this expression, we open the brackets of this expression and we found out that 90 degrees minus 90 degrees is 0 and minus minus is plus. So in total this expression equals to alpha. That is to say the missing angle AOP equals to alpha. This is the missing angle AOP that is equals to alpha. So we focus on the right triangle APO. In this right triangle APO, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, this angle equals to beta. Then I copied the right triangle QOD in the new page and found out the value of tangent alpha in this right triangle QOD. This is the right triangle QOD to the correct from the original drawing. QO equals to X according to our definition, and we just right now found out that QD equals to 12 units. And this is angle alpha. In this right triangle QOD, tangent alpha equals to x over 12. Okay, tangent alpha equals to x over 12. Then I copied the right triangle APO in a new page and I found out the value of tangent alpha in this right triangle also. This is the right triangle APO that I copied from the original drawing. Angle AOP is alpha and AP equals to 12 units in itself. You can see here that PO in total it is equals to 7 plus x. Again, PO equals to 7 plus x. PO equals to 7 plus x. So in this right triangle APO, we will get that tangent alpha equals to 12 over x plus 7. Again, tangent alpha equals to 12 over x plus 7. So we have two different expressions for tangent alpha. Equation number 1 and equation number 2. In the next step, we created equation number 3. According to equation number 3, tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12. It must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 2 is 12 over x plus 7. So in total we found out that x over 12 equals to 12 over x plus 7. Because multiply this equation, we found out that x times x plus 7 equals to 12 times 12, that is 144. We open the brackets on this side of equation number 3 and found out that x times x is x squared plus 7x equals to 144. We subtracted 144 from this equation and found out that x squared plus 7x minus 144 equals to 0. So here we have a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we get the value of x according to the special formula that x equals to minus b plus minus root of b squared minus 4 times ac over 2a. Here also a, b, and c are the coefficients of this general quadratic equation. And then again, x is the variable that we are looking for. I remind you that according to our definition, x is the length of this line segment QO. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to c, and the coefficient c equals to minus 144. Now we put this data in our equation in order to find out the value of the values of x. According to this equation, we get that x is equals to minus b. B is 7, so minus b is minus 7, plus minus root of b squared. B is 7, therefore b squared is 7 squared, that is 49. Minus 4 times a is 1, times c is minus 144. So inside the root we have minus 4 times minus 144 is plus 576 plus 49. In total, we will have inside the root 625. So in conclusion, we found out that x equals to minus 7 plus minus square root of 625 over 2. So x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32. Over 2 is minus 16. So in conclusion, we found out that according to the first solution for x equals to minus 16. But because of the fact that x is the length and the length must be a positive number, we cancel this solution for x that is a negative number. So we're left only with the second solution that is possible for x, that is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, we found out that the length of this line segment 97 QO equals to x equals to 9. QO equals to 9 units in its length. Then our mission is to find out the area of this green shape. We divided the area of the green shape into 3 parts. The first part is the area of the right rectangle APO that we defined as A1. The second part is the area of the green rectangle OQD. We define the area as A2 plus the area of rectangle PCDQ. We define the area of the rectangle as A3. It is obvious from the drawing that the area of the green shape in total equals to A1 plus A2 plus A3. We calculated each part separately and then we added the three areas together. It must be equal to the area of the green shape. So repeat again. The area of the green shape equals to A1 plus A2 plus A3. In the next step we calculated each area separately. A1 is the area of this green triangle APO. AP equals to 12. PO equals to x plus 9. X plus 7 plus x. And x is 9. So in total PO equals to x 7 plus 9, that is 16. So A1 is the area of this green right triangle APO. The area of this right triangle APO equals to AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is 96. So in conclusion, we found out that A1, that is the area of this right triangle, equals to 96 square units. Then we calculated the area of A2. A2 is the area of this right triangle, QOD. QD equals to 12, and QO equals to x, and x equals to 9. The area of this right triangle QOD equals to QD times QO over 2. QD is 12, QO is 9 over 2. 12 over 2 is 6, and 6 times 9 is 54. So the area A2 of this right triangle QOD equals to 54 square units. Plus the area of A3. A3 is the area of this rectangle PQTC. The area of a rectangle is the length times the width. The length is PC 12 and the width is PQ, that is 7. Again, the area A3 is the length of the rectangle times the width. The length is PC, that is 12, and the width is PQ, that is 7. So the area is 12 times 7, that is 84. In total, the area of the rectangle is equal to 84 square units. So actually we found out that the area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. 96 plus 84 is 150, and 150 plus 84 is 234 square units. So in conclusion, we found out that the area of this green shape, according to the first method, equals to 234 square units. We finish with the second method. Then I presented to you how to find out the area of the green shape according to the second method. In the second method, we join points A and D together by straight line. By joining points A and D, we created the right green triangle ACD. And copied the right green triangle ACD here. AC equals to 24, CD equals to 7 units according to what is given us the equation. We implemented on this right triangle ACD the Pythagoras theorem in order to find out the length of the hypotenuse AD. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 square, that is 576, plus CD square. CD is 7, therefore CD square is 7 square, that is 49. So in total AD square equals to 576 plus 49. That is actually 625. So AD square equals to 625. We took a root out of this equation and found out that the hypotenuse AD equals to the square root of 625, that is 25. So here AD equals to 25 units in its length. Then we completed this quarter circle to a circle. Angle AOB equals to 90 degrees because AOB is a quarter circle. Point O is the center of the circle. So point O is the center of the circle. Point A is the point of the circle itself. Therefore AO is the radius of the circle that we defined as R. Then we extended the radius AO by a certain until it touches the circle at point M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of the circle that is equal to R. So we have chord AM that passes through the center of the circle, that is to say it passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle, and the length of the diameter AM is R plus R, that is 2R. Okay. Then we extended the straight line CD by straight line until it touches the circle. We assumed that the extended side CD did not touch the circle exactly at point M, but in any other point, for example at point N. Then we got a contradiction to rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, peripheral angle MAN equals to 90 degrees, and therefore it rests on MN, that is the diameter of the circle. And because of the fact that peripheral angle ACN equals to 90 degrees according to what is given in the equation, it must rest on AM. But according to our assumption, it rests on chord AN, that is not the diameter of the circle. This contradiction to rule number 5. In order to avoid the contradiction to rule number 5, we must conclude that the extended side CD will touch the circle at point M, only at point M, and not in any other point. And there we will not have any contradiction to rule number 5. Why? Because we have peripheral angle ACM that is equal to 90 degrees, and this peripheral angle ACM indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay, so we have here CM, it is one straight line, because we extended the straight line CD by straight line, the result CM is a straight line. So CM or CDM is one straight line, and CM in total equals to CD plus DM. That is to say, CM equals to CD, that is 7, plus DM, that is 25. Before that, we have to prove that DM is 35 units. So, we focused on this side of the straight line AM at point O. The sum of the angles on this side of AM at point O must be equal to 180 degrees. So which angles we have at this side of AM at point O? We have this angle that is 90 degrees, therefore the missing angle here must be equal to 90 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. In the next step, we proved that the green triangle ADO is congruent to the right triangle ODM. Why those two triangles are congruent to each other? First of all, AO equals to OM. Side AO in the green triangle equals to side OM in the white triangle. They are both the radius of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is the common side that belongs to both triangles, so side OD equals to itself. OD equals to OD is the common side that belongs to both triangles. So actually proved that those two right triangles can go into each other according to side angle side rule, and from the fact that those two right triangles can go into each other, we derive that AD equals to DM. AD equals to DM. AD equals to DM according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AD and DM must be equal to each other. But AD equals to 25. So we can write that AD equals to 25, and from this equation 25 equals to AD equals to DM, we derive that DM also equals to 25 units. Here DM equals to 25 units in its length. So in total CM equals to CD plus DM, because CDM is one straight line. So CM equals to CD, that is 7, plus DM, that is 25. 25 plus 7 is 32. So CM in total equals to 32. AC equals to 24, and AM is the diameter of the circle, that is 2R. So copy the right angle ACM in a new page and related the Pythagoras theorem on this right angle ACM. This is the right angle ACM that occurs from the original domain. I repeat again that AC equals to 24 units according to what is given us in the question. We just right now found out that CM equals to 32 units, and AM is the hypotenuse, AM is the diameter of the circle, is equal to 2R. We implemented the Pythagoras theorem on this right angle ACM. According to the Pythagoras theorem, AM squared equals to AC squared plus CM squared. AM squared equals to AC squared plus CM squared. AM is 2R, so AM squared is 2R squared, that is 4R squared, and it is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to 576 plus 1024, in total it is 1600. 4R squared equals to 1600, we divided this equation by 4 and found out that R squared equals to 1600 over 4, that is 400. We took out of this equation and finally found out that R equals to the square root of 400, that is 20. So the radius of this circle R equals to 20 units. Then we implemented the Pythagoras theorem on this green right angle AOD in order to find out the missing side OD. This is right triangle AOD that occurs from the original domain. We know that AO is the radius that is equal to 20, the hypotenuse AD equals to 25 units. According to the Pythagoras theorem, in this right angle AOD, AD squared equals to AO squared plus OD squared. AD is 25, therefore AD squared is 25 squared, that is 625. And it is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400 plus OD squared. OD is the missing side, so we leave it as it is. So in conclusion, we found out that 625 equals to 400 plus OD squared. We subtracted 400 from this equation, and finally found out that 625 times 400 is 225. That is equal to OD squared. We took out of this equation and finally found out that OD equals to the square root of 225, that is 15. So the missing side here, OD equals to 15 units in its length. What is the area of the green shape? We divided the green shape into two parts. The first part is the area of the right green triangle AOD that we define as A1. And the second part of the green shape is the area of the green triangle ACD that we defined as A2. It is obvious that the total area of the green shape equals to the area of this green right triangle AOD, that is A1, plus the area of this green right triangle ACD, that is A2. So in total, the area of the green shape equals to A1 plus A2. Repeat again, the area of the green shape in total equals to A1 plus A2. A1 is the area of this green right triangle AOD. AU equals to 20, OD equals to 15. So the area of this right triangle AOD is AO times OD over 2. AO is 20, OD is 15 over 2. 20 times 15 is 300, and 300 over 2 is 150. So in total, we found out that A1 equals to the area of this right triangle AOD, that is 150 units, 150 square units in its length, in this area. Then that is A1 plus A2. A2 is the area of the right triangle ACD. So this is A2, that is the area of the right triangle ACD. AC equals to 24, CD equals to 7 units according to what is given us in the question. So the area of this right triangle ACD is AC times CD over 2. AC is 24, CD is 7 over 2. 24 over 2 is 12. So in total, this expression equals to 12 times 7, that is 84. So A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. Again, the total area of the green shape equals to A1 plus A2. A1 is 150, A2 is 84. 150 plus 84 equals to 234 square units. In conclusion, we found out that the area of this green shape, according to the second method also, is equals to 234 square units. Okay? Thank you very much.